No, go ahead. I like we really did good. No, my face so good. And they like I just like really knowledge. And I got there. I don't know what sure, but oh yeah.
Okay, let me check their homework, guys. Later on. Like, yeah. Okay, got it. Okay, thank you.
And then this.
Oh,
okay, I don't have a lot. Wednesday.
I already have. Yeah.
Yeah, I ran out of time. I didn't have time to check.
Yeah.
So I actually like this one, like
I was gonna play with like they were. I was there. I used to. I'm like every time. So it's not like you take my.
I don't have so much for. Let's get put me in the class. All this stuff that you do. I don't really know what it is. That's Either way, it was just like. Like, see what he about to get out here, it's like, he was like,
Like when we did.
Is that like a everything? I don't know. Yeah, bro.
I see your. Yeah. Maybe you know.
Oh, no, no. It's like that white.
That's where we're. Like, yes, me. Well, you guys.
Okay, so.
Seniors for gold.
Because like.
Yo, you don't really.
Oh,
Yeah. The range.
So on Friday, we started going over our quiz review. We went through pages 1 and 2. The keys attached. And then today in class, we're going to go through pages 3 and 4. I will walk through these problems with you because, yeah, I want to make sure that you understand how to answer these types of problems. And then page 4 is just product rule, quotient rule, and evaluating derivatives. So we'll go through page 3 together. Page 4, I will have you guys try on your own, but I'll also answer any questions that you guys have. Couple of things that's coming up. Tomorrow morning, I will have a morning quiz review. So I have handouts for that morning quiz review. If you want to pick one up, just for any, for review on your own, or if you want to come in tomorrow morning to go through the review with me, I will send out a Teams link if you want to join online. I'll also record that session. But your quiz is going to be on Wednesday. Tomorrow, we're going to start our next unit on chain rule, but it's not going to be on the quiz. This is going to be, this is so that you guys have an extra day to study, but then also don't lose the day of instruction. So that's why we're starting the next unit before your quiz. And then Wednesday's quiz will be no calculator. So you can leave your answer unsimplified and that will be fine. 2 more things. I want us to sign up for AP Central. So with 10 minutes left in class, I'll have you guys get your phones and you guys will sign up for AP Classroom. And if you're unable to do it now, I will text you and make sure that you have the information. You can sign up on your own device if you're not able to do it on your phone. Okay. And I just found this information out that your AP exam is going to be hybrid. It's going to be semi-digital. So what that means is all your problems will be in a digital testing application, will be in a Blue Book digital testing application. But the good news is that you still get to do everything on paper. I'm assuming that they'll give you a scratch sheet for the multiple choice section, and you can transfer that onto your bubble sheet. And then the free response, you're still going to be working in a booklet. So you're still doing everything booklet, the problems will just be displayed on screen. So so I think I'm glad that it's still on paper because I would hate for students to have to figure out notations to do on, it's just, yeah, it's a mess. So I'm glad that it's still for on paper for the most part, but the problems will be displayed on screen. So I don't know exactly how that's gonna look come AP exam time, so we'll figure that out when we get there. But that's what's gonna be a little bit different about your AP exams this year. I'm assuming your other AP exams will probably experience that same either full digital or hybrid come next May. Any questions about our calendar up to Wednesday? Okay, so let's go to I think we got through pages 1 and 2. Let's go to page 3. Okay, why don't you have to try this one here? I think you can do this on your own. Use a table to estimate the value of b prime of 120. Again, you're estimating a derivative, which means estimation. We're going to use an algebra version of calculus, which is slope. Indicate the units of measure and then explain the meaning of b prime of 120 within the context of this table. Let's try that. Okay, so 16, we want to choose points that's closest to our target. So we want to be as accurate as possible. Based off of the limit data that we have, we can choose 60 and 180 as places that we can find the slope because that's the closest to 120. So we do the change in position over the change in time. And you can leave your answer unsimplified because no calculator on the quiz. But this ends up being 3.3 feet per second. So this means that the approximated rate of change of the rate of change of this particle is at 120 seconds is estimated to be 3.3 feet per second. All right, any questions with 16? Okay, let me talk through number 17 here. So 17 says, is the function differentiable at x equals 2? So let's talk about what that word, here, differentiable. What does that mean, differentiable? How does the graph look if it's differentiable?
Like jagged.
Right, smooth curve, right? It's got to be, so a graph has to have a smooth curve. And to determine that, we know that by itself, these two graphs are functions, right? They're both continuous. So there are no breaks in the graph, but we don't know, is there going to be a break at x equals 2, right? So we're going to test continuity condition at x equals 2 to see if it is connected. So we need two things to happen. We need the graph to be connected, and it's got to have a transition from one graph to the other, sharing the same y value, but also sharing the same slope. Yeah, if they don't share the same slope, there's going to be a sudden transition in steepness, and then we'll be able to spot the fact that the graph is not differentiable, that graph is not smooth. So we have to confirm two things here. So the first thing is we need to confirm continuity. You know, do the two graphs share the same y value at x equals 2? So I can just step through my continuity conditions. So the first condition, does the point exist? F of 2, we know it's with the second piecewise. Second condition, does the limit exist? We can do one-sided limit. Direct substitution. Approaching 2 from the right, also direct substitution. We can clearly see that the limit exists. And now the third condition, we go back and see, are these in agreement? The order pair is at -11, the limit exists at -11. The order pair, the graph is continuous at x equals 2. So that's one piece that we need to establish, right? That there is no sudden breaks at x equals 2, that they're actually meeting at the same y value between the two graphs. And now the second thing is, can we confirm that they actually share the same slope, right? If they don't share the same slope, even if they're connected, they're going to have a sharp turn, right? Or a sudden change, and that is not differentiable. So we also need to confirm that the graphs share the same slope. So what that means is we have to basically look at their derivative and see if they actually are in agreement at their derivative. So I'm going to find f prime, put it into piecewise form so I can have access to that. So I can just go through a power rule to find each of their derivatives. So if I plug in f prime of 2 for both of these, are they going to share the same slope? Yes, right. So This confirms that the graph shares the same slope. They share the same y value at x equals 2. They share the same slope at f prime. But you don't have to show this work here. But just to kind of let you know, if we were to step through continuity conditions for f prime, then that would, if we can show that the f prime function is continuous, that would show that the function is differentiable. Right? So differentiable just also means continuity at the f prime level. If f prime has the slope existing, and that the approach of the slope from both sides is also the same y value, same slope value, then our graph is differentiable. So we can say that since f of 2 equals -11, and we've confirmed that f prime of 2 is equal to -9, we can therefore confirm our function is differentiable at x equals 2. So they share the same points, they share the same y value, and they share the same slope. So that leads into part number 18, because 18 is where we want differentiability, but we have to create those restrictions so that we can actually find the a and b values so that they can meet these criteria that we need. So 18 says, what values of a and b would make the function differentiable at x equals 4? So the strategy here is, let's set these equations equal to each other because they must share the same y value, first of all. They must connect at x equals 4. And then we can set their derivatives equal to each other because they must share the same slope at x equals 4. So if we have two separate equations that we can build out of this, then we have the ability to solve for a and b because we're going to have systems of equations and use one equation to solve for the other. Or use the two equations to help us solve for one variable at a time. So this is a kind of a popular type of AP exam question where testing of students understand what is needed and be able to understand that derivatives is needed to help us set up one of the criteria, and then also setting up the equations to equal to each other. So let's do the part that doesn't require the calculus first, which is we can set the equations equal to each other, right? We know these two graphs, they must share the same y value at x equals 4 because we're trying to achieve continuity and differentiability. So I'm just setting the two equations equal to each other. I can replace every x with what? 4, because we know that they must share the same y value at x equals 4. We're concerned about what is happening at x equals 4, so replace every x with 4. So a root 4 plus b times 4 squared minus 1 equals 16 over 4 plus 4b. We're not able to solve for a and b because we still have two remaining unknown constants, but we have something that we can work with later on. So I have 2a plus 16b minus 1 equals 4 plus 4b. Combine my like terms there. So 2a equals 5 minus 12b. All right, so that's one piece of the puzzle. The other piece is we need to confirm that they actually share the same slope. So our strategy there is we're going to set the derivatives equal to each other because these two branches, they must also connect in a way where they must also share the same slope. Otherwise, it's not going to be differentiable. So let's build the derivatives for both of these functions. But to get these ready, so I can just do power rule, how can I rewrite this a root x? That ax to the 1/2, I can rewrite that out. And then I would prefer not to go through quotient rule. If I don't have to, I can rewrite this so I can just do power rule by writing it as 1. Yeah, 16x to the -1. Yep. So now I'm going to find f prime for both of these segments. Power rule. Remember, a and b are just constants, right? So there's no need to do product rule. Treat a and b like you would if it was like a 3 or a 4 or 5. It's just some coefficient that's going to hang out in front. What's the derivative of ax to the 1/2? Bring down the 1/2. What does that look like? Good. 1/2 ax to the -1/2. Good. What is bx squared? Its derivative. 2bx. Yeah. So that b is just some coefficient. It just hangs out in front. There's no need for product rule. The -1 goes away. And then what about the derivative for 16x to -1? -16x to the -2. Okay. What is the derivative of bx? Just b, right? If it was 3x, it would become 3. Bx would become b. Okay, so we'll set these equal to each other. And then replace the x with what? 4, yeah. Okay, try that. The numbers get a little messy, but I think on the quiz will be better. But even if it wasn't, you can leave your answer unsimplified. More concerned about the setup here. Okay, so if I set these derivatives equal to each other, I'm going to replace all the x's with 4s and then do some cleanup. So 2 times 2 is 4. So a over 4 plus 8b equals -1 plus b. I would like to work on this equation without having to deal with a fractional value. So I'm just deciding that I want to multiply everything through by 4. So I'm just having to make the numbers larger, but that way I can avoid a fraction. So a plus 32b equals -4 plus 2 plus 4b. I'm just deciding that I want to solve for a. It doesn't matter which one, but now I have 2 equations, and I need 2 equations to help me solve for one unknown constant at a time. It doesn't matter which constant you solve for first. I just came across a here, so I'll replace -4 minus 28b in for the a of the other equation. And now I'm just trying to get it down to my solving for b. And once I solve for b, plug into the other equation and solve for a. Again, you don't have to yeah, you don't have to get it all the way down to just one number. As long as you plugged it in, even if it's unsimplified, you'll still get credit. And I think that the quiz, the numbers will be a little bit easier on the quiz. But the process is what's important. This process is a common type of problem on the AP exam. Okay, any questions here? Okay, if you look at number 19 and 20, 19 and 20 says, each limit represents the instantaneous rate of change of a function. Identify the original function and the x value of the instantaneous rate of change. I also want us to find what this is asking for us to find. So what we're going to do is we're going to interpret what this is asking us, and then we'll just transition to what we know using power rule. So here's 19. So we have limit as x approaches 4, x squared minus 3x minus 4 over x minus 4. This is really an application, or basically working out the alternate definition halfway through without getting it all the way through. But we have the pieces that we can fill out where it's coming from. So this is coming from the alternate definition, which is limit as x approaches c, f of x minus f of c over x minus c. So if we can recognize that that this is really working out that alternate definition, can we tell by comparing this, what is the function that is being referred to? Our function is just what? Yeah, just that, right? That's the first piece, and that's f of x. So my function is x squared minus 3x. And we know that this is representing f prime of c. What's our c value? 4. So it's really asking, what is f prime of 4? So now, if we know what the function is and what it's asking for, there's no need to rely on limits, right? We can just go through power rule and find this derivative because that's what this is asking. So what's f prime? Yeah, 2x minus 3, and then plug in the 4. So this is how limit definition can be applied. It's recognizing what it means and recognizing what it's asking us to find. Now, if you look at number 20, 20 resembles more the general definition. Let me write the general definition so we kind of match the parts here. Okay. This has a lot more things kind of getting in the way of seeing what we need to see. But this is also asking for the derivative at a point. Ignore the 5 for now. Can you tell? The 205 is not very helpful because it got evaluated, so we don't see the function. But can you tell what the function is before it got kind of changed up in the definition? You see through the mess to identify what the function was. Okay, I'll tell you where to look. What's the function that this came from? Basically, this is x plus h, right? So if I remove this, this is coming from f of x. So if I should replace this with x, what does that function look like? Get 9x minus 10x squared. When we went through, when they went through limit definition, they replaced every x with x plus h, and so that's where that x plus h and eventually the 5 came from. So we can still piece together, but just have to understand, okay, this is showing that limit definition halfway and then trying to backtrack and figure out, okay, where did this come from? Now, what is this asking for? This is asking for f prime of what? 5. Yep. So that x is replaced with 5. So that's indicating f prime of 5. And now there's no need to look at this notation anymore. We have once we know what we're trying to look for, we can rely on the rule that's a lot more efficient, right? We'll find the derivative using power rule, plug in 5 to get the slope. So our derivative is 9 minus 20x, plug in 5, we get a slope of negative 91. Any questions? Okay, let's go to the last page, and I want you guys to see, let's see how much we can get done in the next 10 minutes. So can you recognize the need for product rule? Can you recognize the need for quotient rule? Apply them accordingly. Okay, so try that. Oh, yeah, okay, yeah, I had the negative as part of it. Okay. Okay, so 21, do we see the need for product rule? We can't worry about the -2, right? The first thing to take care of is we have to build our derivative before we can figure out the steepness at that point. So go through product rule. Once you build your derivative, then you can replace every x with -2 and then work your way down to a numeric slope value using your table. Part C, we also have to go through product rule, f prime g plus f g prime. Build out your derivative in function notation first. Once you have your derivative built out, then you can replace all your x's with -2s. Number 22 is asking when is the function have a horizontal tangent? So horizontal tangent means slope equals what? 0. Yeah. So we just set that to find the derivative, set the derivative equal to 0, and then solve for x. 23, you're evaluating the slope involving trig. So make sure that after you find the derivative, plug in pi over 3, we've got to go one step further. We have to evaluate those trig values, and we can't leave it with that trig notation there. We got to get it down to a ratio.
Straight up all like straight. Daniel's like, multiplied by 2 and stuff.
24 and 24 A and B are just describing or interpreting the meanings of those notations. And 25 is just finding slope.
I would think each one. 8 years. That their side. Yes, I think. I think maybe there's.
And you will have to know how to evaluate a limit using general and alternate definition. I do have that on the morning review, so, but the advantage is that you can do power rule to double check all your answers, so, we do need to be able to do that as well. Okay, so we have about 10 minutes left. Would like for you guys to, there's no homework except to study for your quiz. And then morning session, help session tomorrow. You guys can come up, get your phones. You can sign up for AP Central. I'll put the join code here.
I know it's. I guess it's like, I guess I'm just gonna do that. That's covered.
She made the emails.
We get. You're on my phone. Yeah, what is it? Virtually.
Just so that can make it, yeah, voices. We actually have graduate.
I appreciate it. There's like really sort of new members of me and right here, those things right here. It's just like, just to get the fire here.
No calculus. The numbers are changed, but it says it's a case for the change. Then it's just one point. Basically, if they ever give you 2 points, it's always just like.
Oh, yeah. Yeah. I'm so true.
Okay, you guys see this? This is, so you gotta go to, apcentral.collegeboard.org. Most of you guys already have an account. Make sure, double check your email address is your personal and not your account, not the whole account email address. And then, you're gonna go to the join, you're going to go to, register for AP exams and join course. And then, BC Calculus, all of both second and third period are gonna use the same join code. So it's PMZ 4R6. So. First off, know that this coming from the general, alternative definition, right? So.
You're enjoying it.
Wait, how do you know?
Right.
Yeah, well, I.
Well, it's either alternate or general. And the general is agency. This is the first alternate text of function. So here's general, there's alternate. First off.
Don't even know, he said.
So I just, if we match this up, it goes, oh, this is. I have. So.
It's like base math, it's like the whole thing.
Oh,
And this is asking for the derivative as that's so small. I'm start seeing that take back. So basically saying find f prime is 1 or function. And after that, we don't have to worry about this anymore. Let's just solve this problem. Alternate is always the next function.
What do you do after you get?
We just go through, pretend like this is on a separate problem. So go through quotient rule. It's a limit, I think, but this is a little bit.
So how many dollars?
Right, so here's the.
Which one?
Yeah,
Like, we're doing like,
You're kidding me.
but I'm not.
Can you tell what? But some of them don't.
Yeah.
Yeah, but like.
Okay, I know.
Like, when we're, I'm putting something.
Imagine you took this out. What's the input?
On the word down.
So the function is just.
You'd be like.
And the text it got changed. It may not have, so this has to prime. But the idea is that, I just go to find the derivatives. Well, the derivative rule, you got like, is the state to you.
Yeah.
But, but the idea is like, find the derivative.
So it's 2 weeks.
It's down. Oh, I'm like 4 days. Well, look at normal lines and parallel, yeah, so.
I remember.
Parallel is just. I'm just grab this. Parallel is just. Something is.
I think she probably, I don't know. So she was. And I never see like from the text. Wait, like, I feel like I would.
It's last, I didn't want to knock it off you, for sure.
Cause I would. Or like, it's not-
I think you should have. It. You know.